planet behind the pretty picture. Forget everything you think you know about Saturn, the ringed planet, the calendar photo, the screensaver. Before this video is 2 minutes old, you need to hear this. Saturn isn't pretty. It isn't a toy. It's one of the most violent, bizarre, and downright unsettling environments anywhere in our solar system. And for decades, it kept its darkest secrets hidden, until the James Webb Space Telescope turned its eye toward it and found things that left scientists genuinely stunned. Things no planet should be capable of, things with no explanation, things that are forcing researchers to rethink what a planetary atmosphere can even do. This is what Webb just uncovered. And by the end of this video, you'll never look at Saturn the same way again. Saturn isn't just large. It's large in a way most people never really grasp. It's the second biggest planet in the solar system, trailing only Jupiter, with a diameter roughly 9.5 times that of Earth. Hollow it out and you could pack in about 760 Earths. Then there's the wind. Saturn's equatorial winds regularly top 1,000 km/h. Not a typo, over 1,000 kilometers an hour as a baseline, not during some rare storm. Earth's fastest recorded hurricane winds hit around 400 km/h. Saturn blows past that more than double every single day, planet-wide, permanently. And then there's the North Pole, where things get truly strange. Sitting there is one of the oddest structures ever found anywhere in the known universe. An enormous, unrelenting storm, but not a round one like every other storm we've ever observed. This one is a perfect hexagon. 6 straight sides built entirely from swirling clouds and gas, spinning around the pole for more than 40 years, ever since the Voyager probes first spotted it in the early 1980s. Sit with that for a second. A geometric shape, holding steady in the churning atmosphere of a planet the size of Saturn. The hexagon spans roughly 20,000 miles. For comparison, Earth's entire diameter is about 7,900 miles, meaning this single storm is more than twice as wide as our whole planet. Winds inside it howl at around 300 Nm, and the eye at its center is 50 times the size of a typical hurricane eye on Earth. 50 times. It's been rotating there, holding its 6-sided shape, for decades. Scientists point to jet streams, fluid dynamics, and resonance effects in the atmosphere as the likely cause. But even with those explanations in hand, the hexagon remains one of the strangest single objects in the solar system. 10 hours that changed the picture. Here's the catch, though. Until recently, all anyone could study was the hexagon itself. The lower clouds you can actually photograph. What was happening above it, in the stratosphere and the electrically charged ionosphere near the top of the atmosphere, was almost a total blank. The light coming from those upper layers is incredibly faint. Too faint for ground telescopes, too faint even for earlier space telescopes. Nobody had ever gotten a clear look. That changed when Webb aimed its near-infrared spectrograph at Saturn's North Pole and simply stared for 10 straight hours of continuous observation, watching the planet turn beneath it. The instrument was tracking infrared light from H3+, a charged form of molecular hydrogen that acts like a natural tracer, lighting up the stratosphere and ionosphere in a way that finally let scientists map layers of Saturn's atmosphere nobody had properly seen before. What turned up floored the research team. In the ionosphere, the outermost charged layer, sitting roughly 1,000 kilometers above the visible surface, scientists spotted something never before seen on any planet, anywhere. Inside the glowing auroral rings, circling the North Pole, embedded like shadows on a bright halo, were a string of strange, dark, bead-shaped features. Distinct patches, strung together like a necklace, floating high above the planet. They held steady for the full 10-hour run, but comparisons across different observation windows showed them slowly drifting over longer stretches of time. Nobody had a name for them. Nobody had seen anything like them. Existing atmospheric physics offered no explanation. The study's lead, Professor Tom Stallard of Northumbria University, heading a team of 23 researchers spanning the UK, US, and France, put it about as bluntly as a scientist can. The features were entirely unexpected, and for now, entirely unexplained. That statement comes from a peer-reviewed paper published in Geophysical Research Letters in August 2025, and in scientific terms, it's about as loaded as it gets. When career atmospheric researchers say a result is unexpected and unexplained, it means the data doesn't fit anywhere into current models of how the planet works. And the dark beads were only Act 1. About 500 kilometers lower in the stratosphere, Webb's instrument caught something equally strange, and in some ways even more visually arresting. Within the methane emissions of that layer, the team found a star-shaped pattern radiating outward from the North Pole toward the equator, a shape that seemed to echo the hexagon's 6-fold symmetry far below. Except something was off. Only 4 of the 6 points were there. 2 arms were simply missing, leaving a lopsided, broken star reaching out from the pole, its remaining arms lining up with some, but not all, of the hexagon's corners. The broken star. Then came the real surprise. When the team laid the stratosphere map, the ionosphere map, and the known position of the hexagon on top of one another, the star's arms pointed directly above the hexagon's corners, and the darkest of the ionospheric beads sat right above the strongest of those stratospheric arms. Structures, separated by hundreds of kilometers of altitude in completely different atmospheric layers, appeared to be linked. Think about what that would mean. If these layers really are connected, the hexagon isn't just a cloud-level weather pattern. It may be shaping or being shaped by processes happening hundreds of kilometers above it, reaching up through the stratosphere and into the ionosphere. Some kind of vertical link, energy or information or both, passing between wildly different atmospheric layers at once. Nothing like it has been documented on any other planet. Not Jupiter, not Uranus, not Neptune, not Earth. Webb had one more surprise up its sleeve, and this one closed a mystery that had frustrated scientists for 4 decades. Since Voyager 1's 1980 flyby, researchers have struggled to pin down how fast Saturn actually spins. Sounds simple enough, until you remember Saturn has no solid surface to track, just gas all the way down. So scientists instead relied on radio signals tied to its magnetic field and auroras as a stand-in for rotation speed. Voyager 1 clocked it at roughly 10 hours, 40 minutes. When Cassini arrived in 2004 and measured the same signals, the number had shifted by about 6 minutes, and kept shifting in the years that followed. That's a genuine problem. Planets don't just change their spin rate. Doing so would require some huge, currently unexplained transfer of energy or angular momentum. For 40 years, researchers debated whether the readings were flawed or something truly strange was happening at Saturn. Webb settled it. Analysis of the same November 2024 observation, published in the Journal of Geophysical Research, Space Physics in March 2026, revealed the answer, and it's stranger than most expected. Saturn's spin never changed at all. The measurements were off, not because of instrument error, but because of Saturn's own atmosphere, Saturn's planetary heat engine. Here's the mechanism. Saturn's aurora, its version of the northern lights, forms when charged particles funnel down its magnetic field lines and slam into the upper atmosphere, heating it in the process. That localized heat drives powerful winds. Those winds, moving through the charged ionosphere, generate electric currents. Those currents alter the very auroral signals scientists were using to time the rotation, throwing off every reading. And to close the loop, those same currents feed back into the system and power the aurora all over again. Aurora heats atmosphere, atmosphere drives wind, wind generates current repowers aurora, and around it goes a self-sustaining planetary heat engine, running on Saturn's own magnetism and light that happened to fool every instrument aimed at it for 40 years. Stallard called it a planetary heat pump. The aurora heats the atmosphere drives the winds generate the currents that power the aurora, and the cycle just keeps going. We'd known for decades that something was distorting the rotation readings, and later traced it to atmospheric winds, but the why behind those winds stayed out of reach, until this observation finally closed the loop. A 40-year mystery, resolved by 10 hours of watching with the right instrument. Step back for a moment. Saturn isn't some far-off exoplanet. It's practically next door in cosmic terms. We've studied it through telescopes for over 400 years and sent the billion-dollar Cassini spacecraft to orbit it for 13 years, from 2004 to 2017. We thought we had a solid handle on how it worked. Then, Webb looked with sharper eyes than we'd ever had, and in a single 10-hour session found dark beads no one knew existed, a broken star nobody had seen, hints of connections spanning hundreds of kilometers of altitude that no model predicted, and closed a rotation debate going back to the 1980s. That's the humbling part of Webb's work. It keeps showing us that even the planets we've studied for centuries still hide entire layers of complexity just past the resolution of our older instruments. Build a sharper eye, and the universe hands you a new layer of strangeness. The dark beads are still unexplained. The missing arms of the star are still a mystery. The exact mechanism linking the hexagon to the structures far above it is still being worked out. Webb answered some long-standing questions, and opened up a fresh set that scientists are only starting to dig into. Why Saturn keeps surprising us. Meanwhile, Saturn just sits there, 886 million miles away at its closest, ringed in ice and rock, its equatorial winds topping 1,000 km/h, its geometric superstorm still spinning at the pole, its broken star and dark beads still drifting above it, its auroral heat engine still humming along. There's something worth sitting with here. Why does Saturn, out of all 8 planets, keep surprising us in ways no other world quite matches? Jupiter is bigger with its own storms and magnetosphere and atmospheric complexity, yet Saturn keeps producing phenomena with no real parallel elsewhere. The hexagon alone makes it one of a kind. No other gas giant has a persistent geometric polar storm. Jupiter's polar feature is an oval, Saturn's is a hexagon. That asymmetry took scientists decades to even begin explaining, and its stability across 40 plus years, in an atmosphere with wind speeds that would tear apart anything on Earth, is still remarkable, even with the mechanism broadly understood. Then there are the rings. Beautiful from a distance, astonishing up close. The ring system stretches roughly 282,000 total kilometers outward from Saturn's center, yet in most places, the main rings are only about 10 meters thick. You could line up multiple Mount Everests across their width, while the rings themselves are barely thicker than a 5-story building. They're mostly water ice with some rocky debris, ranging from grains smaller than sand to chunks the size of houses, and within them are waves, spirals, clumps, gaps, braided structures, and mysterious dark spokes that appear and vanish. A constantly shifting system shaped by the gravity of Saturn's many moons. Webb has turned its infrared eye on the rings too, and the results look nothing like the familiar pale bands from visible light images. In infrared, the highly reflective water ice makes the rings glow blue. The poles take on a strange gray-green hue at wavelengths that probe the upper atmosphere, and the cloud bands reveal chemistry and depth invisible to ordinary cameras. In 2024, Webb and Hubble observed Saturn 14 weeks apart, letting scientists effectively slice through the atmosphere at multiple altitudes and assemble the most detailed three-dimensional picture of Saturn's atmospheric structure to date, revealing a planet that isn't one atmosphere but dozens of distinct layers stacked together, each with its own chemistry, temperature gradients, and wind patterns, all interacting in ways researchers are still mapping. A solar system within a solar system. And then there are the moons, 146, confirmed as of the latest count more than any other planet. Most are small, irregular captured rocks, but a few rank among the most fascinating objects known to science. Titan, Saturn's largest moon, is bigger than the planet Mercury and wrapped in a thick nitrogen atmosphere more reminiscent of early Earth than anything else we know. It has lakes, rivers, and seas, filled not with water, but with liquid methane and ethane, with methane rain falling from its hazy orange sky. It's considered one of the most promising places in the solar system for prebiotic chemistry, if not life as we'd recognize it. Then there's Enceladus, a small ice-covered moon hiding a global liquid ocean beneath its frozen crust, kept warm by the tidal squeezing of Saturn's gravity. Cracks near its south pole vent geysers of water vapor and ice into space, a plume that Cassini flew through and sampled directly, finding water, salts, carbon dioxide, hydrogen, and organic molecules, essentially the basic ingredients life on Earth depends on. Whether Enceladus's hidden ocean could host microbial life remains one of astrobiology's most seriously debated open questions. All of it, the rings, the moons, the hexagon, the dark beads, the broken star, the self-sustaining aurora, the 1,000 km/h winds, exists within one planetary system, all within range of our telescopes and eventually our spacecraft. Saturn isn't a single discovery, it's a solar system within a solar system, with every ring, moon, and atmospheric layer still holding secrets we're working to unpack. And Webb managed all of this, closing a 40-year rotation mystery, revealing atmospheric structures with no known parallel, assembling the most detailed infrared portrait of Saturn's layers ever made, essentially as a side project. Webb's main mission points far beyond our solar system, toward exoplanet atmospheres and the earliest galaxies in the universe. Saturn is just one stop on an itinerary that spans the observable cosmos, and even in passing, it's rewriting what we know about our nearest giant neighbor.